Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI. I am Vangelis and today you will be watching Safety Part 3 C# and Java vs Rust, Parallelism and Mutation. So before going into the FFI series, I was watching yesterday a video by Venkat Subramanian here, as you can see in the DevOps conference, and he was talking about design patterns revisited in modern Java, as you can see, and he reached the point where he started talking about iterators, and at this specific point he described a bug communicated to him by a fellow developer. And he said that when he turned this into a parallel stream from a simple stream, the code stopped working. So what he was doing, the developer, he was creating an iterator, he was filtering by some predicate, he was mapping, and then with the for each, he was adding his result to a new collection here. Of course, this whole pattern is bad because you don't need for each and you don't need to add it to a new collection because map returns a collection. But anyway, this is still possible to be done, and this developer was doing it, and turning this simple iterator to a parallel iterator broke his code. So we know that this does not work in Java, yet it is allowed. So I wanted to recreate this in C# and Rust and see the results, and this is exactly what I did. And the first program that we will see is this C# console application. And what we do is we define a names list here, and we just create an iterator with where we filter by the length, and then we create an uppercase name and we add it to our collection. So we add the upper name. Of course, this is also a bad pattern because with select it's like mapping, so you don't need to add it to a new collection because you get a collection. But as I said, this is allowed, and this is code that has been written so far. And we are trying to see the results. So this is a normal iterator, no parallel iteration. So let's run it, and then we console write line the count, the result. So let's run this and see our result. So let's say .NET run. Okay, we have our result, and the result is 538. Let's rerun. 538. Clear. 538, 538, cool. Good enough. Let's go to Rust. Again, we define our array with the names. We create a new vector for the uppercase names. We iterate. We filter. The name should be 4 characters long. And then with the for each, we uppercase the name and we push it to this collection. And then we print. So let's run this. So clear cargo run. 538, 538, 538, 538. So we have the same result. This is excellent. So now let's get into the parallelism. I will comment out this iterator and I will enable this parallel iterator. This is an API available in .NET 7, and this is what I am currently running, .NET 7. Of course, it does not map one-to-one. We cannot filter with where here, etc. So we do it the imperative way here, and we do the same. We check our condition and then we add to our collection an upper name case of the name. So let's try to run this. So you see the results start doing some crazy stuff. As you can see, each time we run it, we get a different result. Which is crazy, of course. So as we can see, the same parallel mutation and iteration breaks in C#2. As you can see, we have parallelism here, parallel for each, and we have mutation here because we are adding to this collection. So this is obviously broken. So let's check our Rust version now. We will utilize the Rayon library for our parallelism, and what we simply have to do is comment out the simple iteration here, iterator pattern, and enable the parallel iteration. So let's check our results. The result is, as you can see, that the code does not even compile. As you can see, we have this result at the for each, cannot borrow as mutable. So while we are parallelly iterating, we cannot borrow this collection as mutable. So in other words, we cannot mutate while we are making a parallel iteration. So this code doesn't even compile, and this of course protects us from the bug that we will get during runtime, and the bug that we see is here. Both C# and Java are susceptible to this bug. This bug happens in these languages. So as you can see, again, once more, Rust protects us from ourselves, and the compiler guarantees that we will not write code which is buggy. And in this case, it is buggy. For a non-experienced developer in Rust, this may seem a little cryptic. He may not understand what he says, that I cannot borrow as mutable, etc., because he may be quite accustomed to other languages like C# or Java. But as you can see, Rust is correct in this specific case. In this specific case, too, I would add. So this is all I wanted to share with you. Till next time, guys, peace.